We're live!
Yay!
This is Read the Source, episode number 21. And we're going to be talking today about NativeScript. And our guest today is TJ VanToll. Is that how you pronounce it?
Yep.
Awesome. Can you just tell us a little bit about yourself?
Yes, I'm TJ. I work for a company called Telerik. I'm coming to you live today from my office here in lovely Lansing, Michigan.
Woohoo!
Yeah, middle of Michigan, so we're right about here. So I've been with Telerik for about 3 years. Before that, I was a longtime web developer. Did web development for a good decade or so. I spent some time on the jQuery team, and for the last handful of years, I've been working more on the mobile app world. So seeing how web developers can get into the Android and iOS world, which is sort of what logically led me into getting involved with NativeScript.
Pretty awesome. Today it's just me and Cornell are going to be asking some questions. I know you're going to go through some code, and we're going to get to see some demos with, or some code snippets at least, and how that integrates with the code of NativeScript on GitHub. So that's I think it's github.com/NativeScript/NativeScript. Is that correct?
Yep, correct.
All right, cool. All right, so Cornell, you have anything to add before we get started?
Nope. I'm excited.
All right.
Yeah, it's awesome stuff. Go ahead, TJ.
All right. So I got to find which screen to share. Let's see. I think you're going to see a little Hangouts Inception for a minute. Tell me when you see some slides.
Slides.
Right, excellent. Okay, so as I said, my name is TJ. I'm going to be focusing mostly today on code. I have a super complicated agenda here. I just wanted to take a second to set the stage a little bit with NativeScript, so you have an idea of where we're coming from, so why we felt the world needed yet another JavaScript framework, where the idea came from, and then most of the time I'm just going to dive into some examples so we can actually see some code behind this. Now, the backstory with NativeScript starts with Telerik, and which is the company I work for, which the entire NativeScript team is under the Telerik umbrella, and we are now part of that little bottom ticker there, Progress Software, as well. Now, if you've never heard of Telerik before, we are a software development company. We're sort of best known for our UI components. If you've heard of Kendo UI, we are behind that, but we're also behind a number of mobile products as well. And really where NativeScript got started is we are still spending a lot of time in the Cordova world. So the Cordova, PhoneGap, Ionic, if you've used any of these technologies before, you may know that really the value proposition behind these things is that it's a best of both worlds solution. That you can take any of the web skills and the web code that you currently have, so JavaScript, CSS, HTML, all of those good things, and build applications that have access to the best of the native world. So rich native apps with all these device APIs. You know, your canonical example of a PhoneGap app being a web app that needs to access things like the accelerometer, the camera, things like that. So at least that's the idea, that it's really a best of both worlds solution. But what we learned at Telerik from sort of years of doing this ourselves, and based off both feedback we got from our customer base, and off us building apps ourselves, is that this architecture, while great for a lot of apps, makes it hard to hit that right side of the equation, the right circle here, the native side. That with a Cordova, with a PhoneGap app, it becomes really difficult to build these extremely rich native experiences using this architecture. And we sort of known this because we've spent years trying. We maintain pretty much the largest Cordova plugin listing outside of Apache's own site. A lot of these plugins we've built ourselves or we've contracted out. And all of these plugins, really, a lot of the idea behind them is to push the boundary of what you can do with a Cordova with a web-based approach in a native app. So you'll see things like native page transitions. You can see 3D touch is the top thing listed on that list. But what we found is that although this approach works well for like certain device APIs that you need to access, if you want to build just the best possible user interface, the best possible native app, you really need a clean architectural break. And that's really where NativeScript got started. Really, early prototypes of NativeScript began 2 or 3 years ago. It's been in the works for quite a long time. Our 1.0 release was last May, and I think we had a public beta that was a few months before that. We recently announced NativeScript 2.0, and we've got a couple other things in the works as well. Now, before I go into code, if I just succinctly state what NativeScript is. NativeScript is open source. As mentioned, everything is up on GitHub. It's Apache 2 licensed. I'll show how you can contribute, look at some of the source code today. And really the idea behind NativeScript is trying to deliver on that promise of hybrid applications. So on one hand, we want you to be able to build no compromise, truly native, performant native apps. So we're using native user interface components. We're not using a web view. We're not using a browser, no HTML, no DOM. But at the same time, give you the ability to build those apps using JavaScript, optionally using TypeScript and Angular, using CSS to actually style. So we're trying to give you that best of both worlds approach. And so with that sort of pretense or setup out of the way, I'm going to dive. I think we're going to get some, let me move this screen out of the way. Don't have Hangouts Inception here. And actually look at what a NativeScript app looks like, how it works, how the code and things all come together. Now, the first thing to know with NativeScript is that when you develop NativeScript apps, you're going to use the NativeScript CLI. And like a lot of things with NativeScript, the CLI is built on top of NPM. So if you wanted to get started, you would npm install -g NativeScript to actually install this thing. And if I were, I'll show a few of these things, how they relate to the code that's actually up on GitHub. So the NativeScript CLI itself is at github.com/NativeScript/NativeScript-CLI. The CLI is actually written primarily in TypeScript. I think that, let's see, GitHub's, yeah. Most of the code is actually written in TypeScript. It's registered up on NPM, so you can contribute to this as well. And you'll find there the code that actually automates the way that you work with NativeScript applications. I won't go over that too much today. It's part of the code base I'm not terribly familiar with. But once you get this command actually installed, you'll have two little commands you can use from your terminal, both NativeScript or TNS, TNS being short for Telerik NativeScript. There's just a little shorthand you can use to do all things you need to do with your NativeScript apps. Now, you use the TNS create command to actually create NativeScript apps, actually scaffold out an application. I have one that I've sort of pre-scaffolded here in the background just to save us some time, and I have some little snippets set up so that we can go through this without taking all day to look at this code base. And before I dive too much into this specific example, I just want to give you an idea of how NativeScript apps are actually structured at a high level. Now, if you look at this, the first thing you might notice is the package.json file and the node modules folder. Now, if you've done node development before, if you've just used NPM for like package management in a front-end app, you probably recognize these conventions. With NativeScript, as I sort of mentioned earlier, we really try to take the best or sort of these established conventions from the front-end world and use them as much as we reasonably can as part of building native apps. And so you'll see, for instance, in my package.json here, for instance, it's what we use to do our sort of configuration for NativeScript, which is what this is here. We also use it for dependency management. So a lot of the code we'll be looking at today is in this TNS core modules dependency that we also store on NPM. But you can also use some other things as part of your NativeScript apps as well. These are a handful of NativeScript plugins, which we use NPM to store all of the plugins that we write, that our community writes as well. You can also, since NativeScript apps are just JavaScript code, use random NPM utility modules. This app I need to do a little bit of email validation. A lot of people use like moment for date and time formatting in NativeScript, Lodash and underscore. Any of these utility type NPM modules that aren't tied to the DOM tend to work fairly well in NativeScript apps. So node modules and package.json. The other thing to note is this app and platforms folder, because that's sort of the crux of how NativeScript works here. This platforms folder actually has your Android and iOS native applications. So I mentioned earlier, we are building truly native apps here. We're building Android and iOS apps. We're not doing anything we're wrapping with the web or anything like that. And this platforms folder is just where we stored that code. So on Android, you'll find things like Gradle configuration files and jars and all the various little things that you need to build an Android app. You can find the same sort of thing in the iOS folder. You'll find, let's say, your Xcode project, for instance. This all hangs out in here. But the cool thing is, with NativeScript, we actually treat these things as generated code, and in most cases, literally as generated code. And this project, for instance, I'm actually just ignoring this from source control because I'm going to be using the NativeScript CLI here in a moment to actually generate this platforms folder. So we're generating your actual native apps here. So because of that, most of your development actually happens in this app folder, and that's where we'll be spending basically all of our time today looking at the various code that makes up this application. So in app, you'll see things like JavaScript files. I'm using TypeScript in this application. Also some CSS files, some markup files as well. This is where the core of your actual app is going to be. But to show how like these pieces come together, I'm actually going to just run a NativeScript app real quick. You can use the run command from the NativeScript CLI. I'm going to pass the emulator flag because I want to kick this off in the iOS simulator. And what this is doing, so this is the code again. What's running here is the code in the NativeScript CLI repo here. And what we're doing is we're actually using the Xcode command line tools. So the same things are running here that would run if you had built a native iOS app in Xcode here to actually build this thing. The files are getting placed in that platforms folder here. And this usually takes about 15 seconds. We'll see how lucky we are today. And that'll actually kick things off in the iOS simulator here, which I got to jump the size down on a little bit here. That's a little too small. Get it here. And then this will actually launch my app up here. I've just got a simple hello world here, so there's not much magic going on at the moment. What's cool though, and I'll dive into what these specific files do here in a minute, but this login file here is where the actual hello world happens here.
Yep.
You can see this
TJ, just interrupt for a second. Sorry.
Yeah.
I just had a quick question about that. Is that if you see a TypeScript file and a JavaScript file with the same name in that directory, does that usually mean that the JavaScript is a generated file from that TS, or is it just that you have the compiled ones as well?
It is. Yep. These are generated, and actually, I've been meaning to. With my editor, I think there's probably some way in Sublime Text I can actually hide these things so you don't see them. I do have them in Git as being ignored, so they don't appear in source control because they're generated. But I got to do some research to figure out how I can not see them in the editor, because it is you see a bunch of code that looks like this. It adds a little bit of clutter. And I should say that the TypeScript code here, as well as the Angular code that I'm using here, is optional. At the end of the day, what the NativeScript runtime is going to use is JavaScript code. So what our CLI did, and I didn't really actually even mention under the hood, but this hooks folder, the one hook folder we didn't go over, what it actually does is it has a hook that, here it is here, is actually taking care of the TypeScript compilation for us. So the NativeScript CLI is doing this under the hood, and that's why I was able to just run this app, and my TypeScript code sort of automatically was used to generate this. But did that answer your question?
Yeah, definitely. Sorry to interrupt on that one.
Oh, no worries.
Thing though.
Then that actually leads into what I was going to show next, because the cool thing about this approach, and remember, like normally you'd be building this sort of app in Xcode with either Objective-C or Swift, and the cool thing about using JavaScript is that it's an interpreted language, and we actually are interpreting these files at runtime. And what's cool about that is what I can do is once I have my app built, so you saw the initial build took 10, 15 seconds, something like that. But I can add a watcher here. So we have this command called livesync that just basically kicks off this little watcher. And what it'll do is watch my actual development files. So everything that I have here in app, it's going to watch for changes to these files. And what it's going to be able to do is there's no longer the need to build all of this up again, that process that we saw the first time, because that app is already in place, and these are just interpreted files. So all I'll have to do is change this file. So I'm just going to change hello world to hello world 2 here. And that was the first change it picked up. Yeah, it just picked up on the next one. And all the CLI has to do at this point is it's going to be a little bit slower because I'm using TypeScript code. It's going to detect the change that I made to the file. It'll actually compile the TypeScript code into JavaScript code, and then it'll relaunch the app with the change. Did I do something wrong? Let me see. Let's make it hello world 3. I think I might have screwed something up when I set that up. But we should see it get kicked out there. And the cool thing, there we go. We're working on making this a little bit faster with TypeScript. This is actually, if I were building this with vanilla JavaScript, we've got this down to basically sub-second, but it's usually something around 3 or 4 seconds once TypeScript is involved in the process. So that's basically how this works. Let me bring my notes over here. Now, I won't go too far in depth with the Angular code that appears here. I think there's other places to learn Angular, and so don't focus too much on the Angular code here. What I will say is that if you were to take this Angular component here and say, like, toss it into a web app, you're just building your vanilla web app, this would basically run exactly the same with one key difference. You may notice that this UI component here, if you're writing this on the web, you'd instead write this as like label, it's lowercase, and then the value appears in here. So things look a little bit differently. So this sort of begs the question, how does this actually work? Which gets at the core of NativeScript and sort of how this process happens. Now, the first thing I'll show here is I guess the coolest thing about our architecture, and what I'm going to do, give me a second here. I'm actually going to switch over to Android. So I got this app up and running on Android before we got started today. I'm going to start an Android watcher here because I want to show something specific to Android. So I'm going to start the watcher there. And I'm going to alert something that's going to look a little bit weird. I'm going to alert java.lang.string. And I got to do this mess because the TypeScript compiler doesn't like when I use this variable because it doesn't know what it is. So I'm going to sort of hack around this for now. Now, if you tried this in a web app, of course, java.lang.string is not going to be defined. The JavaScript VM doesn't know what that is. But if I run this, I just picked up on the 3 change. It'll log the alert here in a second. But if I run this in a NativeScript app, this is actually going to be defined. Because really the crux of our architecture in NativeScript is that we make these native APIs, really all native APIs, Android and iOS, available to TypeScript and JavaScript code. And really everything you see built in NativeScript builds upon that core concept. And I won't go too far in depth. Yeah, you can see there's the function there. I won't go too far in depth in terms of how this works other than to mention that if you think about the way that a browser uses a JavaScript virtual machine, so the V8, the piece of C++ code essentially that runs the JavaScript code in the browser has to tell V8 about things like the window object, the document object, browsery things that are needed to make a browser work, a web browser work. Things that aren't part of the core JavaScript spec, like the window object isn't in the ECMAScript specification. It's specific to the browser. So V8 has to have a way to let the browser register those types of APIs. Well, the core of our architecture in NativeScript is that we tell the JavaScript VM, so on Android we're running V8 as well, about all of these native APIs. And the cool thing about that is it makes a lot of fun things possible, which brings me back to this label example that I have here. The reason this works is this label, and if I dive into the code here, and I'll show this on GitHub too in a minute, is that this is actually coming from this TNS core modules npm module, which is really the core of the code that you're using when you're building your NativeScript app. And there's a UI folder here, and I have a label here as well. And I can open the Android implementation of this, and you can see things like, for instance, new Android.widget.textView, which is actually being used to render this control that you see here. So this is not, remember, there's no browser here. There's no web view. This isn't HTML. This is actually a Android.widget.textView that you're seeing here. And where this code comes in, so if I go back over to GitHub here, so I should mention that sort of at a higher level, with NativeScript, we have these repos are fairly modular. There's a decent amount of code that makes up NativeScript. So we looked at the NativeScript CLI repo earlier. You can see there's a number of things as well, but our main repository is just NativeScript. So github.com/NativeScript/NativeScript. And this matches that folder that I'm in Node modules in my actual app here. So these are things like TNS core modules, UI, just to sort of complete what I was looking at in my editor versus what you're seeing here. Go into label, the Android implementation. And you can see that our modules are actually written in TypeScript as well, which is why this file that you see here looks a little bit different, because we only ship the JavaScript code via NPM, so that you're seeing the generated JavaScript code. But if you wanted to get into this to actually see how this works, to really dive in, you could look at this code up on GitHub, get into the TypeScript code to see how these things actually come together. But that's really the big difference between building, say, an Angular 2 app for the web and in NativeScript, is that since we aren't using a browser, since we're not using a web view, you can't type things like H1 or H2 or paragraph, because these are things, they don't exist in the Android SDK. So instead, you're using our UI components that we take care of sort of translating into their native equivalents, both for Android and iOS. So you'll see there's also an iOS implementation in here, and instead of an Android.widget.text view, we're actually using a UI label for iOS. The power here is that you get the ability to you're abstracted away from this. You just type label, and you don't need to worry about what we're using under the hood. But because we make all of these APIs available, you're never restricted by us. So if you are working with an iOS developer that really knew the UI label and wanted to really configure some things, these properties are always available, and you can always dive into them and sort of fine-tune exactly what you want. And this goes back to sort of our guiding principle, or the reason we built NativeScript in the first place, is we wanted you to be unrestricted by us, so that the framework never got in the way just in case you needed to do something more advanced or more nuanced than what we provided out of the box. But at the same time, we want to provide convenient solutions like label, which is why most of the code that you'll see in this repo over here does exactly that. It really abstracts away that native code that can be a bit messy unless you already know how to do iOS and Android development, into simpler APIs that you can use to build your app. And so, wrong snippet. I need number 1 here. Of course, we're still at Hello World, so you're going to need a lot more than a label to actually build up your application. So to just show you what a little more reasonable example might look like, this is how you might build a login screen in your NativeScript app. So I've got, in addition to, I've got 2 text fields, 2 buttons. Now, one thing different between, say, web and native apps is that because there is no browser here, we need a way to sort of tell the native device how to actually render these controls on the screen. So we provide a series of layout components to do that. So stack layout, grid layout being the main 2. In this case, stack layout is our simplest layout. It just says, in this case, stack these controls that you see up on the screen here. I could also make this a grid layout. I could sort of divide the screen into rows and columns. There's a number of different things that you can look at our documentation to figure out how to actually do. But much like before, you'll find the actual implementations of these things down in the source code. So we have layouts here, and you can find, for instance, how all of these different layout controls are actually implemented. They all go down to various iOS and Android controls that are used to lay out these things on the screen. All right. Are there any other questions at this point before I'll move on to something else here in a minute?
I have only one question. Are there any components that are available for only one platform, or is the entire stack of components available for both platforms?
Yeah, so the ones that are in the NativeScript core modules, so the one in here, we make sure that there's one of each, just so that it's consistent across them. Now, with NativeScript plugins, so things that live outside the core, in those cases, you very much could have implementations that work on one platform or another. And you can also split, like, one thing I haven't really shown yet is you can split up your templates. Like, if you really wanted to, you could find different templates for iOS and Android if you wanted to. You could detect, we have Boolean flags like the screen width you're running on, like say tablet versus phone, if you wanted to get that granular as well. But by default, our core modules, we make sure we have an implementation of both for consistency. But if you're in a plugin, then lots of times there are UI components that only make sense on one platform.
Yeah, I mean, the way that you have this structured too, you could just add windows on there as well. It's very easy to read and in the file structure. And like for the 5 people who have the phones out there, but but I mean, I'm sure there's a community for that. Like,
There is.
If you were gonna put this to web, like, I know we talked about earlier too that if there was someone from the community had done some work to port this to HTML. So
Yeah.
my understanding was that like when you use NativeScript or any of the JavaScript API tools, that your view layer is the main piece of code that you cannot share. So can we talk about that a little for a second?
Yeah, sure. And we actually have, there's more Windows demand than you would think. And some of it is because Tellerk, historically, we really got our start in the .NET space. So our user base, our customer base disproportionately cares about Windows, I think, compared to the broader community. But there is a lot of demand for Windows Universal support. So not a whole lot of demand for Windows Phone, but being able to run like Windows desktop apps or run on the Xbox or all those things, there's quite a bit of demand for that. And so we have like a implementation of Windows that's sort of in an experimental state right now that you could look at, and it does exactly as you're saying. It's like .windows.js, and it's the same sort of thing. Then the web, it's tricky, and yeah, as I mentioned earlier, Nathan Walker is his name from the NativeScript community, has actually been experimenting with rendering these things out to the web. And really the trick there is he's tying into Angular's renderer. Somehow, I actually have to look through the source code myself and figure out exactly how he's doing this, but and is just replicating each of these things you see here on the web. And some of those things are relatively easy, like a button is not all that hard to replicate between the two places. Some of them are a lot trickier. The layouts is actually, I imagine, probably the trickiest challenge in here. Some of the other ones, we'll look at a list view in a second, but just because list views work a little bit differently in native and web, it can be tricky, but the architecture makes it theoretically possible. It's just a matter of getting the implementation in place. And I mean, just in general, NativeScript was always intended to be somewhat of an arbitrary runtime. I mean, we focused on iOS and Android just because that's where the greatest demand is, and we do really want to polish that experience just because anytime you add another platform, there's a documentation challenge, a maintenance challenge, an upkeep challenge. So we've been hesitant to expand beyond iOS and Android, but the functionality or sort of the architecture supports it for anybody that wants to take it on, both from a community perspective and so forth. Very cool. So, all right, I will, Von, the other thing I want to show is, you'll see that I'm going to show a few more examples here, but it all sort of builds upon the same architecture of we're sort of exposing the native elements and just sort of building nicer APIs on top of them. And it applies equally to our CSS implementation. Now again, CSS, there is no web browser here, so this isn't the CSS you know from the web. It's not the sort of thing where you could just take your web app's CSS file and just paste it in here. What you're seeing here is actual CSS syntax. So we are using CSS parsers, open source CSS parsers, to actually parse this thing that you see. So it's your same selector, key value pairs used to actually apply properties. But for each of these, we're again interpreting these code and taking each of these keys that you see here, and we have a whitelisted list of these keys that we support, and applying them to the controls, the native iOS and Android controls that you see here. And this, again, this magic happens in the same core module, so github.com/nativescript/nativescript. It's a part of the code base that I'm less familiar with, but there's a styling folder in here. And sometimes these properties are sort of easy to apply. Sometimes they're somewhat tricky. I think I found a tricky example where you can get into some fun iOS land when you actually have to apply some of these things. iOS APIs tend to be nice and descriptive and sometimes verbose at times. But if you're curious, that's basically how this magic happens. This file will get interpreted by runtime, by NativeScript, and then we'll parse this file and take these properties you write here and apply them to the UI components you see on the screen. So there's really an obvious, the advantage of this is that you get to stay in a syntax that there's a good chance you already know, at least the syntactic pieces of it, how to write selectors, how to write key value pairs. The downside is it's not a total CSS implementation. This is one of the repercussions of our architecture to break from the web view, because we can't write CSS exactly as you would write on the web because that layer just isn't there. But we can still do some cool things. So I have an example here. This is app.css. This is just a convention we have in your app of style that you want to apply to your entire application. We also, through Angular 2, they have a little scope style mechanism. So I move my template to another file here and also use some CSS files I have here for scope styles. This is just building on top of what Angular 2 also has to offer. Just looking at my notes here. One other cool thing, so I'm going to expand the complexity of this a little bit just so we can get closer to looking at an actual app and not sort of a hello world experience here. But one cool thing, and sort of the reason that I use Angular 2 and TypeScript in my NativeScript apps is another cool thing is you can borrow on top, or I guess I could say, use some of the Angular 2 isms to do things like data binding. That's just what this ng model is. Property binding, event binding with this tab function here. Now again, when you're looking at this file, these UI components aren't going to be familiar. There's a good chance you've never seen these things or you don't know how they work. But the cool thing is with Angular 2 is that if you choose to learn the syntax, you could go to Angular's own documentation to look at how this thing is actually parsed. We are using Angular directly. The Angular source code is just chilling down here in this folder here. And what we're doing is we're hooking into this and just telling Angular how to actually render these templates in a native environment rather than a web environment. So when you're looking at this code, a lot of these syntaxes is you don't need to learn a new data binding mechanism necessarily, like especially if you're an Angular 2 fan using for your web apps, for instance. These are syntaxes that you can already look at Angular's docs to figure out how to use. You just really have to use these UI components. And as such, it means that you can also share not only some of these same sort of syntaxes, but in some cases actually share code directly between web and native apps as well, because really your differences are all contained in this template. This template is telling you how I'm going to render this thing out in a native app, but there's no reason that you couldn't say take the same template and say, here's how I'm going to render this template out in a web app as well, if you want to, or you could just stick with strictly native and that is fine as well. But one cool thing I want to show you is what this app is actually doing is I've tied this button you see here, this button here to the login function here, so that when you tap it, it runs this little login that you see here, and it's going to log me in. I've got a really simple and stupid list management app here. But what's cool is that if I go into this service, this user service that you see here, which is going to be in this file here, the actual crux of this thing is happening in this call here to post. Now the code here, again, don't worry too much about the Angular 2 stuff. Just know that the magic is happening in Angular's HTTP service here. But what's cool is that if you look at this file, there is not one single line of code that is specific to NativeScript here. And in fact, I'll show in a minute, I actually have a web implementation of this exact same app that uses this backend service literally directly. Sorry, I just lost my Bluetooth mouse there for a second. I know, Bluetooth mice. But the way this actually works is, again, sort of building upon this same architecture. So this code here, this post method, Angular has an implementation of this for the web. And it's going to use XML HTTP request, and they've added a little sugar around that to make this method call possible. Now the reason this works in NativeScript with no changes, again, we're not altering this, we're just getting this from Angular, from NPM directly. The reason it works is as part of these NativeScript modules, if I actually dive in here, you could look and there's this XHR folder here, xhr.js, and we have an implementation of XML HTTP requests that's going to build upon the iOS API. So essentially we're re-implementing XML HTTP requests with iOS and Android code. So this file here, it's actually, this is just a little bit of sugar on top of our HTTP module. If I dive up here just a little bit, I can find my iOS. Oh, there goes my mouse again. And you can see like the crux of doing a HTTP call on iOS is actually here, NS mutable URL request, whatever that is. But the cool thing is that because we API around it, then things like this HTTP post method just sort of work. And it's not just the Angular service as well. Because we have this implementation, a lot of other modules you might find on NPM or elsewhere to do network requests in JavaScript are just going to work in NativeScript out of the box.
That's awesome. Does it work the same for like offline and caching?
Yeah, so that's a little bit different because XML HTTP request doesn't really do offline and caching. We do have this, so the same NativeScript modules, we have what's called application settings, which can really be thought of as basically local storage. You use it somewhat like local storage. And I've requested, or we've talked about literally making this the same sort of shim that you see with XML HTTP requests so that you can use the same local storage API. Right now the API is a little bit differently. Like I think local storage is set item and get item, and we have things like get string, get number, that sort of thing. So the API is a little bit different. I've seen people build shims for native and web that sort of abstract that difference away so that you don't need to know which one of the ones you're actually using under the hood. Caching is a little more difficult, so I'm not exactly sure. There's different ways that you could implement it. And I'll also mention that the other thing that we support is that you don't even necessarily have to use these APIs. Like we have a Firebase plugin, we have a Couchbase plugin. We have a couple of other ones as well. So if there's a popular backend that you're already using for, say, your web apps, you should be able to use those as part of your NativeScript apps as well.
And this is all in the TNS module, so that's pretty cool.
Yep.
I have a question. You know that Angular 2 is using Zone.js for everything that is async. How is this working with NativeScript? Did you have to do something for Zone.js as well, or you just let the Zone.js to monkey patch the XHR HTML request, the HTTP request?
Yeah, so we are using Zone.js. I'm not haven't specifically worked on the Angular interaction, so I'm not exactly sure, but as I understand it, I don't think Zone.js is specific necessarily to the browser. I think it's all about just running things in sort of isolation, right? And I think because of that, it just sort of works. I don't know if we had to monkey patch anything to get it to work or not off the top of my head, but I can show you. Actually, that's a nice segue. If you are curious about how the Angular stuff works, so yet another GitHub repo, NativeScript/NativeScript-Angular, you can find how we're making the magic happen, like how Angular 2 is able to work in a native app. And really, a lot of what it is, like DOM adapter, is so Angular itself has implementations for, I'm trying to remember exactly where this code is, but add child, right? Instead of Angular 2, Angular 1 would call like the DOM methods directly when it needed to perform DOM operations, like add child. Well, for Angular 2, we've been working with them to abstract those things out so that anytime they need to provide a DOM interaction, they're instead coding to some interface. And we code to those same interfaces, except we do native things rather than DOM things to actually implement this. And again, this is not an area of the code I'm familiar with, so I won't pretend that I know what I'm doing in here. But if you are curious, NativeScript/NativeScript-Angular is where that magic actually happens.
Thank you.
Yeah, so there's one last thing I want to show, and then I'll open it up to any final questions that people have. My mouse is betraying me again. The one last point I want to make is, even though I have sort of highlighted here a few different times how this is somewhat web-like, and you're able to use a lot of your same web skills and such and reuse code and some directly as well. I do want to, again, remind you that when you're building a native app, like one of the reasons we did this is we wanted people to be able to build the best native apps they could. And And in some cases, that means you want to think a little bit differently than you would while you're building a native app. So I have two quick examples I'm going to show you here. There's just some things that you can do in native really performantly that you can't really do on the web. So one of the things we do is we have a full animation API that's basically a polyfill of web's CSS animation API that you can use to do various things in your app. You can see I've got a little background animation going on there. There's other things like on the web, so I've got my example here from the web. It's really hard to do some common, oh, my mouse again. It's really hard to do some common list things on the web, like if you wanted to implement a pull to refresh or an endless scroll. But on native, with native SDKs, these are basically just Booleans. And so I can do things like if I need to pick up eggs on the web here, on native, there's just simple Booleans like pull to refresh, and this is trivial to implement. I don't need some sort of virtual DOM hacks or sort of resort to some shenanigans to make that sort of thing happen. And to really, hopefully, bring that point home, you can actually use native SDKs, so native iOS and Android SDKs in your NativeScript app. And so let me bring in one plugin that someone in our community wrote. I'm going to bring in the explosion plugin because everybody likes a good explosion. And what I'm going to do is that instead of making the login screen actually log in, because that's somewhat boring, I'm instead going to make the login screen actually explode. And this plugin, I'll dive into the plugin here in a minute. So now when I click the sign in button, I made the logo explode, and then the second time this is going to explode, and then the whole page is going to explode. So this is something that obviously, like, there's no API to do this on the web. It's just not a thing that you can realistically do. But remember that once you've gone native here, you're dealing with bytecode. So the game has really changed, and sort of the way you have to think about building your application has changed. And the way this is implemented, and I'll dive into the code here. This is Brad Martin from our community wrote this thing. So it's on NPM as explosion field. And it's just a handful of lines of JavaScript code here. And actually, what he's doing is he's using an existing Android library and just wrapping it. So somebody wrote a little Android library that does explosions. And what Brad did is just wrap this up into a convenient NativeScript API so that all you have to do is select an element and just call explode rather than calling whatever this API is, tyrant get.explosionfield, whatever the case may be. So it really just expands what is possible in terms of building your application. So any other questions at this point?
First, I would like to add, if some live viewers have any question, they can use the read the source hashtag. Or usually the questions appear right in the next days after people are viewing the video in the comment section.
Yep.
So we might have to have a look out on the video to see if there are any comments.
Yeah, and so just real quick, and then we'll see if there's any final questions. If you're at all intrigued by what you heard today, or if you're looking to get into NativeScript, the best place to get started, if you go to nativescript.org, there's this Get Started button. You can click here. We have two different tutorials you can go through. One, if you liked what you saw with TypeScript and Angular, that's your thing, you can go through that tutorial. We have another one if you could care less about TypeScript and Angular and you just want to straight to the metal JavaScript, we have that as well. So that's a tutorial it'll take several hours to go through, but it'll help you get up to speed with NativeScript. And I'd recommend going through that first before, if you're interested in contributing to NativeScript at all, just to give you some background knowledge of how the framework works, go into a little more detail than this quick little session was able to get you in today. And then if you want to get involved contributing with NativeScript, as I said, the NativeScript repo is quite big. There's a lot of things in here. The easiest to approach of these repos are both the modules, so the main NativeScript repo, just because it's TypeScript code, and it's fairly easy to get into, as well as the documentation. I always find docs are a pretty easy spot to get involved with. So if you want to be involved as a contributor to the NativeScript docs, that's a good place to get started with as well. And you can reach out to us if you're looking for a good place to get started. I will show that we have I think it's this menu. We have a Slack channel that I'm on, and a number of the NativeScript team, the NativeScript community is on as well. So if you're interested in getting involved, that's a great place to join and just hang out with us, chat with us, ask us questions, and that sort of thing. And that's really all I had. So if do you guys have any other questions? I don't want to take up too much of our time here.
I posted the links as we went through them in on the Google Plus page. So if people want to just go to those links, they can click on there. I might have missed one or two, but I found Explosion Field and a bunch of others. So what I really loved about this, and I was really surprised in a good way, was how easy it was to read all the code, because I've been writing ES6 and I've been working with Angular. So like for an app, and I thought that was really a really good example. But diving into the source code, even the source code is so easy to read, and do you need, like, if you don't know like all the components and everything, and you want to utilize like TypeScript's typings, do you need a certain IDE or anything like that to use that?
Well, so you don't need it, but I would definitely recommend an editor that, if you're going to write in TypeScript, that you use an editor that gives you a good TypeScript experience. Like Sublime, Microsoft put out a really nice TypeScript plugin for Sublime, which is one of the reasons I use it. Visual Studio Code is another one we recommend, just because they have really good TypeScript support there as well.
Yeah, I like that one.
You don't need those, but at the same time, you give up some of the benefit of using TypeScript if you use an editor that doesn't give you the best experience with it. And I'll also say, from just a contributing perspective, one thing I didn't go over is the actual NativeScript runtime. So if the nitty-gritty of NativeScript, like where the actual managing of the JavaScript VM and such happens, is github.com/nativescript/ either iOS-runtime or Android-runtime. And that's so if you're a C++ developer that really wants to dive deep and wants sort of to get into the nitty-gritty of how we make those APIs available, some of the real magic that runs these things, that's where the real fun is, I guess you could say. It's not something I have a lot of specialty in, but if you're looking for a challenge to dive deep, that's where the magic happens. But the cool thing is that runtime really abstracts away a lot of the real hard stuff, so that the modules and the things that live on top of it are actually fairly easy to read and also to contribute to.
Yeah, it's exciting. I was really shocked at how much like code it seems that you're able to share.
Yep. Excellent.
Very cool. So thank you for coming on. I think we're going to wrap up for now.
Yeah.
And this was really great, very insightful, and I like the code examples.
Well, thank you. Yeah, thanks for having me.
All right. So this has been episode 21 with TJ VanToll on NativeScript. Thank you.